Dumelang, Sanbonani, Absheni, Molweni, and hello. I'm Mr. Makitla. I'm continuing with my lesson regarding linear programming. As I said before, this is NCV Level 4 Mathematics, linear programming, as you'll recall from the last lesson we had. Okay, just to touch on the last lesson that we had, a brief recap of what we discussed before. We did speak about several concepts that you need to understand before you can start dealing with linear programming in totality. We mentioned the situation. We did mention the situation that you should be familiar with the straight line equation, linear equations, linear inequalities. We also discussed whole numbers, integers, as well as real numbers. We also discussed several other concepts, which I'm sure you're familiar with now. I trusted that you've had time to go and look at your notes. Just to remind you, we said we're using the Future Managers Level 4 Mathematics textbook. So I trust you've had time to go through your notes as well. With that being said, I just want to discuss one more thing before we get into the problem solving. Okay. The last section, which I did not cover with you, had to do with implicit constraints. What are implicit constraints? These are constraints which are basically implied. We assume that you will generally know this information without us having to clarify or specify it. What do I mean in that case? With regards to apples or human beings or natural objects that you encounter in life, it's highly unlikely for you to have -7 apples. It's either you have an apple or you don't have an apple. With regards to human beings, for instance, it's either there's 2 people in the room or there are no people in the room. You can never have a situation where you have -4 people in a room, or you've got -3 cars, or -1 book. It does not work that way. Therefore, implicit constraints are constraints which are implied just by the statement or based on the actual topic that we're discussing. We will not tell you. Sometimes the problem tells you, or they give you the implicit constraints, but generally in level 4, you are expected to formulate the constraints yourself. So you need to analyze the statement that you're given and apply the constraints as is. As you've seen, the 2 constraints written on the board here simply means that y will be 0 or a positive number, and therefore x will either be 0 or a positive number. We will not be dealing with negative values or negative x's and negative y's in this case. Okay. Now that we've covered the recap and we've discussed what is necessary for us to solve our problems, we can get straight to the problem solving. I would like to start with page 86 in the textbook, Assessment Activity 2.9. I'll briefly read the question for you, for those of you who don't have the textbook. I'll read it only once and then we'll proceed from there on. Okay. Assessment Activity 2.9, question 1 reads as follows. A small factory makes 2 types of washing machines, a standard and a luxury model. The daily production cannot be more than 6 standard and 4 luxury washing machines. There are 12 factory workers and it takes 1 worker to make 1 standard model and 2 workers to make 1 luxury model per day. The profit on the standard model is 600 rands and on the luxury model 300 rands. Lucky for us, in this particular question, we have been given the constraints. I'll just list the constraints on the board for you, then we'll get started. These are the first 2 constraints related to the statement as mentioned above. They mentioned that a small factory makes 2 types of washing machines, and the daily production cannot be more than 6 standard and 4 luxury washing machines. Sorry for just skipping this section. The first thing we had to do was designate what is going to be our x and what is going to be our y. Okay, Based on this problem and the information which has already been given to us, you'll realize that X relates to the standard washing machine, and Y is the luxury model of the washing machines. Okay. The two constraints above on the board tell us something simple. We know that you may produce less than 6 of the standard washing machine, but you cannot produce more than 6. You can produce exactly 6 or less than, but you can't produce more than 6. Likewise, with the luxury washing machine, you can produce exactly 4 or less than 4, but you cannot produce more than 4 per day. Okay? The rest of the constraints okay. Here's one more constraint that they also stated. X plus 2y has to be less than or equal to 12. This is a constraint relating to the number of workers who can work on these machines. Don't forget, we said one worker is required to complete one standard model of the washing machine, and we said 2 workers are required to complete one model of the luxury version. We also mentioned that we have a total of 12 factory workers. I hope the information is clear and we can use it and utilize it. Okay. What I would like to do at this point, which I think will simplify your life when dealing with linear programming, is rewrite this in the form where y is the subject of the formula. In other words, try to manipulate it and put it in the form of y mx plus c. We'll rewrite it as follows. Minus x over 2 plus 6. If you were to rewrite this inequality with y as the subject of the formula, this is what you'll get as your answer. Okay. Already what you can identify here is that the gradient in this particular case will be a negative value. In other words, m will be negative a half, and we've already identified our y-intercept, which is the c value there. C equals positive 6. Okay. We've identified all the inequalities that we need to conclude this particular program, this particular problem, I mean. Let's read through the questions as they ask them, and then we'll tackle each one as it comes. Okay. The first question reads as follows. Draw the graphs on graph paper and indicate the feasible region. That should be simple enough for us once we've rewritten it in this particular format. We'll start with the first inequality and we'll sketch that. Okay. Before we can draw our graphs, as we all know, you need a ruler. Why do we need a ruler? You need a ruler to accurately sketch your Cartesian plane. What you'll notice is that I've sketched my Cartesian plane in the positive x region as well as the positive y region only. Why did I do that? Because what you'll notice in the text as well is that we have implicit constraints. We will not be dealing with negative x or negative y because you cannot have negative 6 washing machines or negative 4 washing machines. You can only have positive values. These are the implicit constraints. I mean, these are the reason for the implicit constraints is what I was referring to at the start, and that's why I've sketched my graph as follows. Okay. Once you've sketched your Cartesian plane, make sure that each portion is equidistant, then you can start labeling it. In this particular case, our values start at 0, and then we'll draw them all the way. 1, 2, 3, 4, 6, 7, 8, 9, 10. I'll just label them up until 10. Okay, in fact, let's go more. 11 and 12 and 13. Likewise, on the y-axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 and 13. If you do not sketch your Cartesian plane accurately, then you won't be able to use your search line method, because your Cartesian plane has to be accurate for us to use the search line method with the correct gradient. Okay. Also, do not forget to label your axes. We said the x-axis is the standard washing machine. So we know that the x-axis is standard machine. We know that the y-axis would be the luxury machines. Feel free to be as descriptive as you wish to with regards to the labels of your axes. Also, if these were labels which had units, I would have to state my units on each axis. Okay. Now that we've done what we had to with regards to sketching the Cartesian plane, we can start drawing the graphs as indicated. The first one, we know that x is equal to or less than 6. That will definitely be a straight line where x is 6. We already discussed the symbols and which region you'll be shading based on the symbols. Less than means you'll be focusing in this particular direction of this line. I hope you're all with me so far. Now we move to the y value, the luxury machines. We know that y must be equal to or less than 4. We move to the y-axis. You'll sketch your line. Based on the symbol that we see, we know that we'll be shading this region underneath the line or below the line. You can already have an idea, you're already visualizing, I'm sure just by drawing these two lines, you already have an idea of more or less where the feasible region will be. It's not yet concluded, we still have one more line to sketch, okay? This particular case, y is equal to or less than negative x over 2 plus 6, okay? Just by observation, I already know that my y-intercept will be 6. What will my x-intercept be? We can simply calculate that. Go back to the original expression. Go back to the original expression. We know that in order to determine the x-intercept, we simply have to equate y to 0. In other words, x plus 2. Wherever we see y, we substitute with 0. That's the solution in this case. So the y-intercept will be 6. The x-intercept will be 12. Now we may sketch our line. Connect the two dots. There are my dots connected. Based on the symbol, we know that y must be less than. In other words, we'll be focusing in this direction of this particular line. Okay. The question asked us to shade the feasible region. So we are not done with the question yet. We actually have to indicate the feasible region so that your assessor is clear that you understand what's going on. Once more, we're mathematicians. We're not necessarily experts on coloring in and sketching. That's not too important. As long as you clearly indicate your feasible region, then I'm sure your assessor will be a happy chappy. Okay, let's move on to the second part of this problem. They say, how many of each type of machine must be manufactured per day to make a profit by using the search line method? Okay, we briefly touched on the search line method, but how exactly do we go about the search line method? The search line method first requires you to create a profit equation. If you look at the problem, they'll clearly state to you that the profit on the standard model is 600 and on the luxury model is 300. In other words, P equals 600x plus 300y. Don't forget, we said X is the standard model and Y is the luxury model. So you make 600 Rand profit on the standard model and you make 300 Rands profit on the luxury model. Once you've written down your profit equation, you'll manipulate it as well and make Y the subject of the formula. How do we do that? By observation and manipulation of this scenario, you'll realize that Y is equal to negative 2x plus P over 300. Why is this important for us? We need to identify the gradient of the profit equation. Having identified the gradient of the profit equation, we are going to sketch a series of lines with the same exact gradient, negative 2. We need to rewrite this profit equation in this form so that we can identify the gradient of the line. Once you've identified the gradient of the line, it's your responsibility and your duty to sketch the lines on the Cartesian plane regarding the initial graphs that you had. Okay? So with that type of gradient, we'll know that for every x value that is 1, our y value will be 2. There's no shortcut to this. I'm simply analyzing this and I can see it because I've sketched a lot of graphs before. But there's no shortcut to this. The best way for you to analyze this and understand it is perhaps draw a graph with simply y equals minus 2x. Then it will allow you to see what clearly is the gradient and how exactly to go about sketching it on your graph. I already know that 1 will correspond to 2 in this case. I'll use my ruler to sketch this particular line. This line now is what we will call the search line. Let me use a different color. This particular line now, okay, looks the same. It's what we call the search line. How do we use the search line to identify either the minimum or the maximum of the feasible region? You must draw a succession of lines with the same gradient. Okay, see if I can do that. A succession of lines with the same gradient. Once again, as I said, there's no shortcut to this. You have to be patient when solving these problems. Any shortcuts will be to your own detriment. Okay, see there. There's my succession of lines, each with a gradient of negative 2. Each line is a different line, of course, because it will have a different x-intercept and a y-intercept. But as long as the gradient is the same, that's all we're worried about at the moment. The gradient has to be the same. These lines have to each be parallel. Don't forget the knowledge that we've acquired before, that if the lines have the same gradient, then they are all parallel to one another. Okay. Now that we've sketched our search line, we can identify the points which the search line touches first and which points the search line touches last. The question though asked us to determine the maximum profit. So we will actually focus on the vertex of the feasible region which is touched last. What do we mean by vertex? We said each of these points which enclose the feasible region are considered vertices. Okay? So the first point, the second point, third point over there, fourth point, and fifth point. These are the points which enclose the feasible region. That means the feasible region is within those particular points. Okay? You use your search line, observe which of these vertices is touched last. What we'll realize is that the vertex that's touched last is this particular vertex over here. Okay. Just for clarity's sake, we said maybe this is vertex A, this is B, C, D, and E. Vertex D is the last point to be touched by the search line. Okay. What are the coordinates of vertex D in this particular case? We know that the x value of vertex D will be 6, more or less. And the y value looks like it's 3. 6 and 3. At the moment, it looks like 6 and 3. We'll double check this. Will correspond. Luckily, your textbook also has answers at the back, so you can double check if you're doing the right thing. Okay, so we will plug the 6 corresponds to the x coordinate. The 3 corresponds to the y coordinate. Go back to the original profit equation. Substitute each of these variables. Where you see x, you substitute the value for x. Where you see y, you do likewise. And you can determine your profit. So it's 600, the 6 there, plus 300 with a 3 over there. Solving this, you'll realize that the maximum profit would be 4,500 by allocating or by using point D. What does this mean for you and I? It actually means that if they produce 6 of the standard washing machines, as well as 3 of the luxury models, that is when they'll be maximizing their profit to 4,500 per day of production. Okay? Oh yeah. We've already answered B and C. They asked how many of each type of machine must be manufactured per day to make a maximum profit. We identified that by identifying the coordinates of vertex D. We said D has 6 for the x value and 3 for the y value. Therefore, they need to produce 6 of the standard type and 3 of the luxury type. They also asked us to determine the maximum profit that the factory can make, which is what we've done over here. Okay, so just to recap, whenever you come across this problem, it's very important, or a similar type of problem, it may not be the exact same one. It's very important for you to first identify what is x and what is y. What is your x variable? What will be your y variable? What does x and y represent in your equations? Okay, once you've done that, it's up to you to read the statement that you've been given and formulate the constraints. When you are formulating your constraints, do not forget that some constraints may not necessarily be given to you, but they are implied. Those implicit constraints, meaning that you can never have -6 washing machines or -3 washing machines. You can only have positive values when you're dealing with washing machines, okay? And certain other scenarios. Think of natural numbers. Think of natural numbers, and it will help you understand implicit constraints easier. Okay. Once you've dealt with your constraints and you've identified all the variables, it's up to you to sketch the graphs. Don't forget, when you're sketching, your Cartesian plane has to have all the points equidistant. Your scale must be of an appropriate nature. You cannot start with 0, 1, 2, 3, and then you start saying 5, 7, 9, 11. You need to have a system that is consistent and it makes all the values equidistant. I hope I'm clear with that being said. If your Cartesian plane is not clearly sketched and it's not measured properly, then your gradient and your search line will not be accurate. It will give you false readings when you are trying to use the search line method. So I implore you and I urge you, by all means, make sure you focus on how you sketch your Cartesian plane. Okay, once you've identified the Cartesian plane, within the problem or the statement, you'll also be given information that allows you to solve the profit, or that allows you to formulate the profit equation. Using the search line, obviously you would have identified the feasible region by that time. Using the search line, you identify the last point which is touched by the search line. That last point is the point that will give you maximum profit. If you are asked for minimum profit, however, you have to observe which of these vertices is touched first by the search line. Okay, so the ones that is touched first will give you a minimum value. The one that is touched last will give you a maximum value. I hope I'm clear with that being said. Once you've done that, it's easier for you to conclude the problem by identifying how many of each type of washing machine should be produced and what is the maximum profit that we should expect from this entire exercise. And that brings me to the conclusion of our lesson today. Please feel free to jot down any questions that you may have had and pose them to us. I am Mr. Makitla, as I've mentioned before. You can find me via Facebook as Fatso Makitla. Inbox me for any problems that you may have there. Otherwise, go to Nkangala TVET College's website and hit us up on our social media pages. We've got a Twitter handle, Facebook page, and WhatsApp as well. We're always ready and available to assist you. So please do contact us by all means. Thank you.